there are three things that really just turn me on, and it's important to get that out of the way. First is obviously security. I wouldn't be here if I didn't like solving hard problems and working with awesome people in just a fantastic domain. Second is data visualization. I'm a huge visual learner. I know there are a lot of people who just learn from reading a couple of things. I learn from diagrams, charts, graphs, visualizations. And so I'm going to do my best to try and interject a lot of those things into the talk today, as well as some funny photos and images. So good morning again. And then the final thing is pedagogical learning models, which basically means I love learning through stories. I love learning through anecdotes. And I hope to impart some of that basically from everything that I've learned in my career. So while we're on the topic of stories, I'll start with the first one. So the first story, basically my career and where I came from and why I'm here and why you guys are awesome. First, I started my career off as a software engineer at NASA, so right down the road at the Jet Propulsion Laboratory. Software engineer on computer-aided engineering projects, so that includes business applications as well as spaceflight projects like the Mars Science Laboratory, et cetera. I did a massive detour in my life, and I went from putting rovers on Mars to social networks, basically MySpace. Big social network at the time in the mid-2000s, growing up in Los Angeles. And by the time I joined MySpace, they were probably around 50 million users, and security was just a massive issue for the company. They were getting attacked by just about everybody. I joined I think about a month or two after the SAMI attack happened, and I think everybody here is pretty well familiar with the SAMI worm and what that was. And at MySpace, I was focused on managing security, and so really just leading the security team. We grew the practice to about 20 to 30 security engineers, testers, et cetera. Eventually, I found myself at the BBC, and yep.
I'm sorry, I'm not familiar with that attack.
The SAMI worm? Yeah, so I'll go back to that. The SAMI worm is effectively a cross-site scripting attack where Sammy, who was a user of MySpace, and at the time Ajax-y things, or Ajax started happening, he figured out an interesting attack vector where we had cross-site request forgery on the MySpace website, and he was able to inject JavaScript into his profile. And when another user who was logged into MySpace went to his profile, it made a request to MySpace's website on the user's behalf, and it rearranged their top eight friends, and they put Sammy in the top 8, and then it adjusted his, and then Sammy is my hero, actually, was the thing in the profile. And it was this awesome hack, and before I got there, I just heard about what was called remediation, right? The remediation cleanup was massive. MySpace had to pull the cord and went back and did a massive amount of cleanup. No, Tom was the MySpace guy. So eventually, I found myself managing technology and security at the BBC. And so the BBC, this big British broadcasting corporation, and I was on the worldwide side, not to be confused with public service, which is the news. Worldwide is effectively the entertainment arm, so if you watch things like Doctor Who or Top Gear, that's BBC Worldwide. So managing technology as well as security initiatives for digital entertainment and gaming. And finally, I became the co-founder and CTO of Previty. And so you see our lovely signage here, t-shirts. If you guys are interested, feel free to get some clothes. We got plenty of them in the boxes outside. Basically at Previty, what we're focused on doing is trying to change the landscape of security for developers. Developers have a really tough time in the security lifecycle, and we'll talk a little bit more about that. But to set some context, this is not a vendor talk at all. So I'm not trying to sell anything. I'm not trying to talk about our company or anything like that. Your time is more precious. My time is more valuable. It's better to just talk about security and talk about challenges and everything that we're seeing. We're all in it together. So let's start with the past. So where do we come from and where are we today? So number one, applications were a lot simpler than they are today. And things were obviously siloed off. I saw this at JPL. I saw that there were lots of information systems built in all sorts of languages and frameworks, and they were just a lot more contained than they are today. Second is that there was this big conception, and again, I saw this at JPL, of where security was assumed to be related to just network firewalls. And there were things like best practices, and there were things like secure resources, but for the most part, it was just really focused on the firewall. And a lot of people thought and truly believed that things like pattern matching via regular expressions could scale, and scale from two different approaches. One approach being that, hey, hey, we can catch absolutely everything with a regular expression, or we can catch lots of things with multiple regular expressions, or they just generally thought that as compute time and compute processes got faster, that regular expressions would just be easier and could just stack on top of each other. So two quotes that I kept hearing, and this is my time in the late 90s, was if it compiles, ship it. And that's just generally the ethos of what the late 90s were about when it came to software development. And I think that if there's people here who've lived through that moment, I think this will definitely resonate with you. And then the other thing that is somewhat controversial is this thing, and I got to work initially in my career as an operations engineer. I started off as a systems engineer. And I can't tell you how many times, and through all the different companies I interned at or worked at, where this notion just kept coming up, where you talk to other operations engineers and you just asked each other, hey, what are we doing from a security perspective? And they would say, oh, it's totally fine. We have a firewall. And yeah, they are. And yeah, you're right. And from going to a bunch of different security conferences, it's definitely a message that's certainly true. So this happened. Well, vendors went ahead and they decided that they were not only going to take and use network firewalls, they were going to create what's now called web application firewalls. You've heard of them. They exist in all sorts of shapes, sizes, and places. Some are physical pieces of hardware. Some are virtualized containers that live in your data center or your cloud, quotes. So what is a web application firewall? Well, it's effectively a proxy that's potentially being daisy-chained off of a load balancer or some other network device, and it's trying to intercept and catch things before malicious things go and hit your application. It makes a lot of sense when you're thinking about the network, but when you're thinking about the application, lots of issues. So 3 key issues that I've definitely observed from WAFs, and I'm sure you guys in the crowd probably have your own pain points with web application firewalls, but anecdotally, here are the 3 things that I've observed. One is what's called learning modes. And someone somewhere who came up with the idea of learning modes has dozens of swimming pools, and it isn't me. And I'll get to what that means in a second. Regular expression pattern matching. So again, we really thought that patterns, and we could catch things with regular expressions, but it doesn't really work, and you'll see why. And the third thing is latency speed bumps. So again, lots of web application firewalls, and lots of proxies that are basically sitting between your end user and the application itself. So it's just another point in the network that's going to slow your application down. So why do I have a beef with learning modes? First, training a classifier is incredibly tedious. I don't know if there's a lot of people here with machine learning or data analysis in their background, but as a fellow quant, I can tell you that whether you're training a naive classifier or a Bayesian classifier, there's lots and lots of issues with it. Primarily, it goes to the second point, which is that training is significantly error-prone. And the reason for that is you're only as good as the data set that you're going to be training your web application firewall or your classifier with. And it goes to the third point, which is what is statistically significant data? Where are you getting that from? Is that staging data? Is that production data? Is it clean? Has it been normalized? Do we know if there are bad payloads or bad events in there? How are we actually making sure that when we're training the classifier that it's real data? And the other thing that I like to typically think about is a lot of vendors come up to us, and when I was certainly at the BBC, a lot of vendors would come up and sell their technology, sell their solution as, hey, we built something really cool that contains artificial intelligence or machine learning. What does that mean? Do you honestly have a neural network running inside your appliance? Do you have a neural network running inside your virtual machine today? And when I think of what a lot of people want, they want an interface that looks like this, right? When you think about like security, you think about machine learning, you think about classifiers, you want something as cool as this, right? In reality, we're left with this. Pretty significant mismatch from what we want and what our expectations are to what's actually out there in the world, right? So to just rip into this a little bit more, I think when you talk to a lot of engineers, when they think about what learning modes are, I don't know how many programmers there are in the crowd, but if you're familiar with data structures, a lot of people think that, is that just a map or a dictionary with an IP address as the key or a hash of the user agent with the route and with counters on the other side that's just being incremented, and if it crosses a waterfall or a threshold? And I was on a message board several years ago where they were talking about the complexity and whether or not the web application firewalls or this sort of approach, what they're doing statistically And the funniest comment on there was somewhat of a trolly thing, but is GNU Chess have better decision-making capabilities than your web application firewall when it comes to understanding patterns and pattern matching. So let's talk a little bit about pattern matching, because we've talked a lot about regular expressions and patterns. Let's dive into what that means and accurately talk about, the key issues here. So how many people here think that you can do things like input validation or query validation solely on regular expressions today? Exactly. And it doesn't work 100% of the time. And I think if you're applying things like DLP, so basically if you're trying to scan for things like social security numbers, if you're trying to scan for things like email addresses, or do input validation for email addresses, et cetera, I think it makes a lot of sense to apply something like a regular expression. But when you're trying to coerce content, or when you're trying to look at free-form content, like in the case of MySpace, lots of HTML, whether it be a subset of HTML or even custom markup, you can't necessarily use regular expressions. We'll get to that why. But why do you want to use regular expressions? Well, one, they are intuitive. And they're intuitive and they're expressive, which means that, again, if you see a pattern like a social security number, digit, 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 dash, digit, digit, dash, digit, 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 digit. I think that's right. And there are two problems, though, with it. One, you can exploit them in a rather trivial way, which is fuzzing. And I'll show you an example in a second. They also don't scale to infinity. When I got to MySpace, we had probably 300 to 400 regular expressions that we were running with every single post request that was coming to the website. So basically, if you were posting a comment, if you were updating your profile, we would run through a battery of hundreds of regular expressions. They're all compiled regular expressions. So I know there's a lot of people who claim that, well, if you compile the regular expressions, it's still going to be fine. Well, you're compiling them, that's fine, they're set in memory, but you're still going to incur the CPU hit of running all those regular expressions. And we had expressions that were looking for weird Unicode characters, because we've all seen the fun, nasty things Unicode can do in browsers like Internet Explorer, especially since a lot of the older browsers didn't enforce really strict rendering, and there are really weird things that you can do with syntax hacks. So take a look at something like this, alert hello JavaScript. This is obvious, we know what this is going to do. There's less obvious ways that you can get this thing through. And we see stuff that goes past the web application firewall or definition-based approaches that do this. It's the same exact thing as alert hello JavaScript. There's not a character in this thing that's a letter or anything like that. And we see stuff like this that go past definition-based approaches all the time. Suppose you built a regular expression now that handles this. What about that? Right? This is just a palindrome of the previous attack. So you build a regular expression to handle the first one. This is still going to go through. This is still going to execute in the application. What now? So a little detraction. So Matt Mick is going to join us for a little bit for a little story time. So when I was at MySpace and the BBC, a lot of people would come by and talk to us about selling web application firewalls. So oftentimes these vendors did the weirdest shenanigan in the world, and it's pretty obvious. Have you ever worked at a company, let's say you've gotten hacked or exploited, and then you've had a swarm of security vendors attack you, send you email addresses, they try to get your phone number, they try and go to one of your colleagues, and they try to simply find a way to stalk you and get to know you? That's basically what it was. At all of these times and all of these junctions, every single time there was a weird hack or an exploit, someone would come along and try to sell us something, try and claim that their technology or their approach was going to be far better than anything else. And it's really annoying because there's not one solution that cures and solves absolutely everything. So I think it's really important to delineate between what we call compliance and actual security. And as someone who's been on the other side, oftentimes you have to check a box, right? You work at a big company, let's say you have legal reasons, let's say your company's public. You have a financial and you have a responsibility to be good to your shareholders, et cetera, and you have to check that box that says whether or not you are PCI compliant. Well, in that audit forms, or in those forms for audit, there's a checkbox that says whether or not you have a web application firewall. And if you don't check that box, you have to prove how you have what's called a corresponding control, as per PCI 6.6. And if you say that you have a corresponding controls, you have to prove it, you have to vet it. And there's a significant amount of work. So a lot of times, a lot of people at companies just want the easy way out. They just want to check the box. And I don't necessarily blame them for wanting to check the box, but at the same time, do they actually have real controls so that when they check the box, they actually have real security on the other side? So where are we today? And what has all of this stuff in the past actually created? So the first is that applications are a lot more complex today. I'll show you a nice, pretty diagram in a second. The second is that application security means a lot more than running a web application firewall. It means running more than definitions and signatures. It means more than running regular expressions. We're seeing all sorts of what we call targeted attacks, things like cross-site scripting, SQL injection, CSRF, and they're happening in the context of the application, not outside the application. And certainly for something like SQL injection, it's happening between the application and the database itself, not just happening in the application. Pattern matching also has limitations. I talked a little bit about DLP. If you've got a form field and you need to validate a phone number, social security number, or email address, fine, use a regular expression. But if you have to do free-form content, if you're looking at database queries, if you're looking at markup that's going back out to the front browser, don't use a regular expression. So when we talk about the environment today, generally what we're seeing, so there's a lot more players today than it was in the past. Before, you had a binary that was just being compiled, deployed to a single endpoint. In a stateless environment, you had a load balancer, and then life was pretty simple. Today it's a lot more complex, probably because of information sharing. The idea is that you've got lots of data coming from a disparate variety of sources. And so what we typically see is the distributed threat model. I'll break that down, what that means. But you've got content coming from the internet, from your regular users, intranet from your own CMS, extranet from your partner and data sources and feeds. Any one of those different sources can be compromised in all sorts of different ways. How do you trust that your partner is actually sending you correct data? Suppose you build an XML, REST, or even SOAP service, depending on how old or legacy the application is. How do you actually know that the data that you're getting is well formed? Are you running it through your own parsers or validators, or are you simply enforcing that based on contract or business prospects, et cetera? Legacy applications are also huge risks. I can't tell you how many times we've gone to talk to companies that say that they've got 20 to 30,000 applications. 20,000 applications. 20,000 applications, that's mind-blowing. I mean, these are organizations that have been in business for more than 20 years, and they've written old applications in C, and they've progressed all the way back up, and now they're building applications in scripting languages like Ruby, et cetera. And they've got a lot of risk because they haven't gone back, and they haven't made sure that those previous applications have actually been secured or tested or battle-hardened. Oftentimes, you get security professionals who build something, and they leave in a year and a half, depending on how frothy the market is, and how does anybody know exactly what that piece of software was? Was there threat modeling? Was there risk assessments done? Also pre-compiled in open source software. And I think this speaks to a lot of people who run things like static code analysis tools, if you're running solutions like Veracode, Coverity, et cetera today. But how are you sure that the stuff that's already been pre-compiled from the past that you're now linking in with your existing projects is safe? What about the open source software that you're pulling in? How do you know that that's doing exactly what it should be doing? I think with open source, it's a lot easier because you have the ability to go and audit the source, but who's actually auditing the source? Is anyone on your team actually going ahead and looking through all those things? There's a mathematical equation here, and it's something that's really hard to put into an actual equation, so I'll just verbally speak over it. It's the fact that you have adversaries today, and they have an ample amount of time to craft an attack. The problem is your application has a split second to defend itself. And there's a huge mismatch here. And I think the other thing that's changed in the last few years is that the economics are such that the hacker is rewarded, your attacker is rewarded today because there's such a low barrier to entry. I can grab any tool. I can grab Burp, Nessus, Metasploit, and I can turn it loose as a script kiddie against your web application. And I can do all sorts of things. And if I find anything that goes through, awesome, right? And it didn't cost me much to perform and understand all those things. You guys remember this? This is what I think of all the time. Especially when you're a high target company or a high target application, the BBC. You have no idea what's going to hit you. And you have no idea when it's going to hit you. And it oftentimes feels that you're up against a wall. I mean, you have no idea what could possibly happen if you're going to get a phone call at 3 a.m. to get called in to do a cleanup, or you're going to have to do something to fix a problem in someone else's code that was written 10 to 20 years ago. So let's put some numbers to this. Quantifying this stuff is actually really dizzying. I spent the last few days traveling on a plane looking over a bunch of different statistics, and I picked out what I thought were some of the most impressive and interesting ones. So according to Gartner, air quotes here, Gartner claims that 70% of the attacks today are happening against the application itself. So that means that while people are trying to definitely go after your network, it means that a lot of people are actually going ahead and trying to hammer the application over and over again. 1% of spending, again, also associated back to Gartner, is focused on AppSec. Only 1% is on AppSec. So where's the 99% going? Is it going to traditional security? Is it going to network security? Is it going to training? Where is that actually going to? 1,000 plus attacks, and this is derived from the Ponemon Institute. They claim that more than 1,000 plus critical attacks are attempted against big average websites or large websites every day. And I think this number is probably a lot higher, considering that you can, again, take any of the existing tools and you can run them across the entire website, subdomains, et cetera, over and over. And then one statistic that we've observed as a company, and I swear, I promise this will be the last time I mention brevity, is that 50% of all UGC that we've observed as a company, especially from protecting the sites that we have, is actually all spam. And this is free-form content that users are posting in comments, profiles, messages, things like that. So why is this number moving up and to the right? Why is this increasing? It seems like, we generally know how to solve this stuff, and I think we figured a lot of the basics in the mid-2000s, but why is this number still going up? I think a lot of it has to stem with developers and development teams. And I think there's just been this huge culture clash between security and development for the long time. I think if you've worked in development, you hate security teams. And if you work in security, you hate developers. Every side calls each other dumb. Every side calls each other ignorant. Every side, if you're a developer, you think the security team is making you do something that you don't need to do. And if you're the security team, you think that every developer has no idea of what a buffer overflow or what cross-site scripting is or how to HTML encode something. The existing tools aren't good enough. And I'll pause here and I'll reiterate that again. The tools today that we have are not good enough. As a developer, it's insanely confusing. When I show up to MySpace, I didn't have a day of security training or security background at all. And I got in there and I didn't know what cross-site scripting was. I learned about HTML encoding. And then I found out that there are other ways that you could encode things. And then I found out about other encodings and so forth and so on. And it's confusing. And oftentimes as a developer, you feel and you wish that a lot of these practices were fused into the framework. So as a developer, you didn't have to necessarily think about it. But that's also too magical. When you go to that extent, you sometimes don't understand what's happening in the execution of something like a web request. We've seen frameworks like Rails, and I think Rails does a lot of great things. It removes a lot of the complexity for building an application and getting your idea from what's in your head to market pretty easily. I think the key problem, though, is there's a lot of magic going on, and unless you know exactly what's happening, how is the router doing what it's doing? How does the controller know to talk to the view? How does it know to pass data to the view? It can be a little weird. So we want to make sure that we're not creating black magic for the developers either, because they're going to find themselves in situations where content is double encoded, where content is double decoded, and where they're doing things like escaping content in places where they simply shouldn't be. I also think we still rely as a culture too much on pattern matching, and I say culture because as developers and security teams, we still rely too much on, hey, something went through, okay, let's run a string replacement, let's run a regular expression, let's prevent this stuff from actually executing. So let's go into a case study I put together. Why do developers actually think that they can validate input with regular expressions, and especially something like HTML? So I don't know if you guys have seen the Stack Overflow post. I wish I had a copy of it here, but there's this insane Stack Overflow thread. I see some head nodding. So there's an insane Stack Overflow thread where they talk about how to parse HTML with a regular expression, and what starts off as the first comment being a one-line regular expression eventually evolves into you have to scroll for days in your web browser and you see this incredibly gnarly regular expression, and even then the first comment is someone creating an exploit to get around that regular expression. Good luck updating it, right? So why don't we take a step back and realize what's actually happening, and why don't we figure out what the problem is? So if we take cross-site scripting, for instance, which is why we would be parsing HTML in the first place, it's something that executes in your web browser. Cross-site scripting is the ability for an attacker to basically execute JavaScript inside your web browser to perform all sorts of activities. You guys already know what those could be. You could redirect someone to a bad website. You could redirect them to a porn website, steal their credentials, horrible, horrible things, etc. So why don't we try and get domain specific? If we know this stuff is going to execute in a browser, what if we thought about what the browser would do? And what if we applied some of those techniques when we came to analyzing the content? So what if we ended up building what I like to call a quasi-compiler? And so if you think about what's happening in your web browser today, there are obviously lots and lots of steps. So there's the network step, which is going to go to fetch content server side. It's going to grab all those payloads. It's going to run through the browser's runtime. And the browser's runtime will be things like, let's run tokenizers. Let's do syntax analysis. Let's build the parser. And eventually it goes to painting pixels into the DOM. And painting pixels is interesting, but that's post-execution, or that's really during the execution phase. If we're talking about regular expressions, we're already talking pre-execution. Why don't we bring the same techniques and the same technologies that web browsers already have today, but do all of that server-side? And so a web browser sort of kind of does this. And if you were to do it server-side, you would have to go ahead and build tokenizers, syntax analyzers, and parsers for things like HTML, CSS, JavaScript. There are a lot of people who think that you can use parser generators today to accomplish this task. You can't. And you can't primarily because every single web browser is very, very different. And for instance, browsers like Internet Explorer allow you to do some really fun things, like you can break things onto new lines and you still see execution. You can insert invalid Unicode, UTF-8 or UTF-16 characters inside your attributes, names or inside your attribute values, and still create execution. What happens when there's a best fit with SQL Server? So when we talk about things like SQL injection, what happens when you're making a request to SQL Server, but the type of the database is in Latin or ASCII? And a Unicode character comes in. Well, I learned this the hard way, is that there's what's something called best fit, where it tries to normalize things in higher character sets to where you are right now, rather than simply tossing the characters. So you can also use things like virtual machines to try and do things like understanding the execution. That would involve things like tracing or hooks. Lots of things you can do. But building a compiler isn't new. It's actually not rocket science either. There's lots of tools, lots of techniques. This mic is crazy. I'm right here. Okay. Cool. Thanks for the... So building a compiler isn't new. Yeah, awesome. Now, building a compiler isn't new. Lots of tools, lots of techniques that you can look at. Pretty trivial to try and build one of them. It's not too difficult. I really don't like shaming people, but in this case, let's actually run through an example payload. So you guys all know that eBay has been in the news this week. Lots of horrible and sad things happening to a nice company. They, as a security team, are exceptionally smart. I know a lot of the security engineers over there. I think they run into what we are running into today, which is lots of legacy applications, lots of development teams, and it's hard as a big security team to stay on top of, all the things that are going on inside of the company. But let's start taking a look at some of these payloads that are going through. So this is a payload that was recently discovered in the last 2 or 3 days. And this particular payload works on labs.ebay.com, specifically in the content or the contact form section. So what do we see over here? Mixed content, right? And this is just what's being sent in the post request over. So we obviously see things like form data, name, but we also see the closing HTML tags, this closing style tag, this closing script tag, this opening script tag, this payload alert 1337, obviously we know what that's going to do. Closing script tag, new line, new line. Well, if we had a compiler rather than a regular expression, what would we see? And I'm going to be naive and assume we're looking at the full payload, including the other directives in the post request, and that includes things like content disposition form data, even though we don't have to. But let's assume even then we wanted to compress everything in the post request and analyze all of that. This is what we would see on the other side of a compiler or through the compilation process. First, we would enumerate all the different tag types. So things like text nodes, closing comment nodes, closing tag nodes, etc. We'd have the values associated with them. So in the case of plain text, we know what that would be. In the case of tags, we also know what that would be. The benefit of having a compiler, though, is we can start doing things like tag balancing. We know what's open. We know what's closed. But we also have the ability to also reconcile that with configuration. So when we see something like plain text, we can run things like HTML encoding if we wanted to. If we see something like a bad tag, we can toss it. If we see tags that are open that aren't closed, well, we can inject a closing tag. Or if we see a closing tag that isn't open, we can get rid of it. We can make content well-formed, and we can do all of this on the server side before content goes back out to the browser or gets persisted again. And so if you run it through this process and you run these decision steps on the right-hand side, you get sanitized output on the other side. And again, crude demonstration, and I even included all the other post parameters in this case, like content disposition, but you get the point. My favorite Tumblr in the world, and a little side distraction, is programmerryangosling.tumblr.com. And this one I absolutely love, because I think it makes a lot of sense, especially when you start going to validate things like HTML. When you want to make content well-formed, you're going to try and understand and analyze it the same exact way your browsers are. And again, this is all pre-execution. And when you want to get into execution, you're going to take it a step further, put it into a virtual machine, understand it, dissect it, hook it, trace it, lots of things that you can do. But again, you have the intelligence to do this on the server side. So how can we improve? I think there's lots and lots of ways. And first, start in a more controversial thing. I think a lot of people believe this to be true. I see this all the time. Even as a security company, I see this all the time. How does someone with a good idea or someone in a security startup compete with a big company like HP? How do you go out there and gain traction in this giant sea where you're being flooded by other companies that are constantly pushing what they consider to be the right solution for everything, a one-size-fits-all approach? It's tough. It's tough being the small guy in the room, especially competing with hundreds of millions of dollars of marketing budget. We all hope that the best ideas will emerge to the top, but it's not necessarily true. Vendor lock-in does create a false sense of security. I think I've seen this again in previous companies where you buy from one vendor and you're likely to buy from another vendor again, and so forth and so on. You bought our firewall, now buy our SIM. Oh, you bought our SIM, now buy this log analysis tool. Okay, and so forth and so on. And then eventually you realize that both your feet are trapped in cement and Tony Soprano standing over you. So I put the Bobs here from Office Space, because I think if there's one thing that's clear, it's everybody needs to be asking, what do we actually do? What do these controls on the security side actually do? Are they actually solving a real problem? Yes or no? And oftentimes just getting your average developer and asking him if he's building the right things, more often than not will lead you to a really interesting solution or at least a good conversation. And at least talking to developers or even security engineers, and you ask them, hey, is this web application firewall or is this solution that we're employing in actually protecting us from something? And forcing them to answer and address the issues actually goes ahead and solves a really good thing. Data aggregation, data collection. So I know you guys have probably heard everybody talk about big data, and I'm not going to mouth off on big data, but I think the one thing that's absolutely true, at least for me at least, is if you could save every memory you've ever had, wouldn't you? Every experience that you've ever encountered, well, what if we could do that? Today, I mean, according to guys like Jeff Hammerbacher from Cloudera at a recent talk, and recent as in earlier this year, and obviously we see the cost of this go down tremendously, that the associated costs with not only disk storage, but also for personnel, for equipment, failover, redundancy, etc., for storing a petabyte of information is roughly $200,000 today. And we've seen that cost drop considerably. I remember in the early 2000s, it was millions and millions of data to store a petabyte of information. And even storing the petabyte of information was gnarly because how are you handling replication? How are you handling failover? What happens if data corruption? I think you guys remember the good old cyclic redundancy checks from yesteryear. So why MVV argument you can totally make. And again, why MVV? Because you don't want to get slapped around. But this totally works well, which is if you want to prove that the value in storing a petabyte of information or storing a lot of this data, you can try and make the claim that your exec in the C-level suite or even your VP with the corner cushy office costs more in 1 year than a petabyte does over multiple years. And again, your mileage may vary for that argument, so use it appropriately. Logging is also incredibly useless. So everything I just said with storing a petabyte of information is useless unless you've got the tools to mine it. If you can't understand or you can't go back and perform forensics or look at forensics, what do you have? You have a ton of data that nobody's looking at and that nobody cares about. We actually want to know what's going on every single step of the way so we can do what we call repeatable data analysis. Learn from our mistakes, repeat our successes over and over again. Understanding what's going wrong or what went wrong takes way too long. I've been able to parachute into all sorts of interesting companies, whether it's through consulting or through this company. And what we've typically found was that a lot of people not only have SIMs, they've got ETL processes that are cumbersome. They've got steps where, let's say, data comes from the website to syslog. Syslog then goes into an ETL. ETL stores stuff into a queue. That data from the queue gets aggregated, eventually gets synthesized into JSON blobs, which eventually gets pushed into something like a Splunk, whereby a certain process were to have to execute on an hourly or an interval to find needles in the haystack. So put the RCA logo here. How many of you are familiar with root cause analysis? Awesome. So significantly important when you work at big companies. When something goes wrong, when there's a big data breach, when PII leaks, you need to be able to go back and you've got your CEO, you've got the CTO standing over you, pointing a finger, and basically in your ear saying, hey, I need to know exactly where we dropped the ball. And if you can't produce a log line that actually says, well, here's the actual problem, well, your tenure at the company is probably not going to be that long, unfortunately. So again, SIMs can be horribly, horribly slow. ETL can be incredibly cumbersome. And as security folks and even as developers, we want the intelligence to know that A, a tree is going to fall down, B, when the tree is falling down and as it's falling down, and C, that the tree actually did fall down and when it did fall down. Finally, on the point of alerting, and I'll stop on this point, if your alert system is predicated on log rotation to identify significant events, you failed. Like if you're waiting like on an hourly window to report a breach or a significant event because that's just what you do because you're piggybacking on your developer's syslog mechanism or anything like that, you failed. And that doesn't work. So I've talked a lot and I'll close off with a few points here. First, when we think about things like the SSDLC, which you guys have probably all heard of, the idea of taking the security or the software development lifecycle and shimming security into it, around it, you've got the first step, which is things like risk assessment and threat modeling. It doesn't stop bad guys. You're just talking about things. And when you talk about scanners, pen test tools, anything like that, that doesn't fix anything. You've just found a problem. Ultimately, it all relies back on the developer. I mean, a lot of things that I've seen is that the developers have, in my childhood here, have way more power than you can possibly imagine. They're the ones that are writing the code. They're the ones that have to know and have to think about security. And unfortunately, when there's a problem that happens, they're the ones that you go to when it comes to, hey, we have to fix the problem. So they're really pivotal in a lot of different steps of the way in the process. So you're not alone. Everybody's getting destroyed. If you're getting hammered today, you're in the company of these fine companies as well. There's obviously plenty more. I didn't even include eBay on here. But going back to the first point that we talked about, this is definitely a hard problem space. And there's not one cure-all. Even if you go down the path of building, let's say, something like a compiler, you're not going to solve every single issue. That's just going to solve one part of one problem. You have to think about all the different pieces. You have to think about what's the right way to build a good security program. And just know that it's difficult. But a lot of really good, rewarding things are difficult. And I think all of us here love challenges. Otherwise, we wouldn't be tinkering with the boards around our neck. We wouldn't be here talking about things like cross-site scripting, how to fuzz things, how to break things. So thank you guys for having me here. So I'll, last few points. Brevity, you can guys email me if you want to party or anything like that. And you can tweet me sweet things at KA. And as a shameless plug, we are as a security company in LA, and we're constantly on the lookout for great security-minded people. We're right here in Los Angeles and proud to be here. So if you guys are interested, stop on by. And if anybody has questions or anything of the sort, happy to have a conversation. If not, we can all just go get t-shirts outside. That works too. Cool. All right, guys. I'll be around.